Now, we'll go to the next concept, that is integration. So, integration is also the reverse process of differentiation, right? So, for example, if I have dy by dx is equal to x square, meaning let's say I have y is equal to x cube by 3. Had the function been y is equal to x cube by 3, differentiate this function and see, you will get dy by dx is equal to x square, because you will get 3x square by 3, 3 and 3 will get cancelled, it is x square, right? Now the question is, when you call this as an equation, right, it is an algebraic equation, or yeah, this is called as differential equation. So what is it called as? It's called as differential equation because equal to symbol is used and you have a derivative. So if they give you the equation and ask you the differential equation, you will differentiate. If they give you the differential equation and ask back the function, you need to integrate. So to integrate, what you do is, this dy by dx is there, no, which is x square. This dy is also a variable, dx is also a variable. You will take the dx to the other side, right? Then you will write dy is equal to x square times dx. And this kind of a process is called as variables separable method, because you separated the variables. You separated y on one side, x on other side. Okay. So if I need to eliminate this d, right, then I need to use an operation like this, which looks in the form of an elongated s. If you take s and pull it, no, you will get a symbol, and that symbol is read as integral of dy is equal to integral of x square dx. Am I clear with this? Right? So integral of dy is equal to integral of x square dx. So basically, this is the operation of integration. I'm not going to tell you what is the answer as of now. This is the process, right? You understood where does differentiation come from? Basically, you will have a function. From that function, if you need the derivative, differentiate it. If they give you the derivative and ask you the function, do the reverse process, which is integration. So integrate it, right? So before you integrate, you follow this method. What is this called as? It's called as variable separable method, meaning you separate the variables on either of the sides. Am I clear with this? Right? So based on this kind of an operation, there are certain formulae that we need to know. So here I will take the integral and here I'll get the function. Okay. So integral of x power n. If somebody gives you a question like this, it is meaningless. So you need integral of x power n with respect to which variable? So it is dx. So integral of x power n dx is going to be equal to x power n plus 1 divided by n plus 1, right? So this is a point to be noted, and another important point to be noted is whenever you have this integral without limits. So integral without limits is said to be indefinite integration. Integral with limits is called as definite integration. So when you write the limits, right, you put a here, b here, or any other variable, where this a is called as the, you call it as the lower limit, and you call this b as the, that's it, You call it as the upper limit. So it is going to be x power n plus 1 divided by n plus 1. So whenever you do indefinite integration, you need to add a constant to it. Okay. The reason why we do that is because this is there, no. So this is the function. If I have to get back this question, then what I need to do is see, if this is given on integrating x power n, I got x power n plus 1. So it is like this. On integrating x power n, on integration of x power n, I got x power n plus 1 by n plus 1. So from x power n plus 1 by n plus 1, if I need to get xn, I need to follow the reverse process, which is called as differentiation, right? So if I ask you to differentiate this, what will you tell me? D by dx of x power n plus 1 divided by n plus 1 plus c. So this is one function, this is another function, right? So what will I get? Derivative of x power n plus 1 by n plus 1 is going to be n plus 1 into x power n the whole divided by n plus 1, because n plus 1 is a constant. So what should I integrate? What should I differentiate? Only x power n plus 1. So derivative of x power n plus 1 is n plus 1 into x power, reduce the power by 1, x power n the whole divided by this n plus 1. N plus 1 and n plus 1 will get cancelled. Plus, what is the derivative of a constant? 0. So on differentiating this x power n plus 1 by n plus 1, what is that you got? X power n, you got this function back. You would have got it, but you need to add the constancy because we don't know the limits. Meaning, if I differentiate this function also, I am getting x power n. If I differentiate x power n by n plus 1 plus 1, I'll get the same answer. Plus 2, I'll get the same answer. So unless you don't know what is the variable that is getting added, you should not leave that constant. You leave that constant only in the case of definite integrals, because you know the limits between which you are integrating. Whereas here you don't know the limits, it can be any function. So that is the reason why we add a constant, we don't multiply a constant, right? So this is the reason for which a constant is added only in which condition? When you do the indefinite integration. Whenever you do definite integration, you will not add the constant. That I'll tell you how to handle it. Am I clear with this idea? Right. Now listen to this carefully. I'll give you the function and its integral value. So integral of x power n dx is going to give us x power n plus 1 by n plus 1 plus c. So integral of, if I have sin x, integral of sin x is minus cos x plus c. If I have cos x, I'll get sin x plus c. So you're able to understand this? So it will exactly be reversed, meaning you don't have a perfect derivation for this. Only thing is, for the function that you have, if you differentiate, you should get back the question. For example, derivative of only cos x is minus sin x. To eliminate that minus, we add a minus here. That is why you get plus sin x. Derivative of sin x is cos x, right? So this is how it works, right? As of now, if you know these three, that is more than sufficient.